Now let's go through the method of solving linear differential equations to see what kind of implications we can conclude about the domain of a solution. Recall that in order to solve a linear differential equation, we need to find the integrating factor. So integrating factor, and the integrating factor is found according to this formula. Notice that if P of t and Q of t are defined on a whole interval, then of course this integration from t0 to t, or P of s ds, so this integral makes sense for all, since P of s is a continuous function. This integral is at least theoretically computable whenever t is anything from the same interval. Right? So in other words, it means that the domain of the integrating factor is still the whole interval I. And another thing that we see is that the integrating factor is actually positive, because it is e to the power of something. Alright? So let's take note of these two things. So we're continuing. So we have our initial value problem, and now the next step is to multiply the whole differential equation by the integrating factor. And the reason for us to write down the integrating factor as, remember that our integrating factor is e to the power antiderivative of p. The reason is because when we multiply everything by the integrating factor, it turns the right-hand side of our differential equation into this very nice form. It's the derivative of the product of the integrating factor and the unknown function. But then we can integrate, so it means that if the unknown mu times y is q times mu, so in order to get the original mu times y, we need to integrate q times mu, and that's why I'm writing this. Well, but now let us solve for the constant. Sorry, no, not for the constant. So first we solve for y of t, right? So y of t is going to be this. So recall that the integrating factor is still a valid function, so it is defined on the whole interval from where t lives. And now let us solve for c. So we need to use the initial condition, right? So when we use the initial condition, y of t0 is y0, then the left-hand side becomes y0, and the right-hand side becomes, so here we have t0, and of course when we integrate from t0 to t0 we get 0, so, and from this we got this formula, right? And recording the formula for mu of t, we finally get the answer that c equals y0. The important part here is that recall that since the integrating factor was defined as the exponential function, so integrating factor mu of t was defined as e to the power the antiderivative of p, so it was t0 to t p of s ds. So in particular it means that it is positive, but what is important is that it can never be 0. So which means that whenever we divide by the integrating factor, we are never going to get into any trouble. So it is possible to divide by the integrating factor. So what we just proved is that if we have an initial value problem for a linear differential equation, then there are three things. So a solution of the initial value problem exists, right? So this is because we were able to come up with a specific formula. It is a very complicated formula, of course, it involves integration, but it is a specific formula. So the solution is unique. The reason is because when we constructed our formula, we always applied equivalent transformations. Right? So when we multiply by the integrating factor, for example, it is never 0, so which means that we could divide back by the integrating factor, so we got an equivalent differential equation, and so on and so forth. So if you go through all the steps, then you will see that they are equivalent transformations. So hence there is only one solution. There is nothing else but the solution that we came up with. And the third thing that we notice is that the domain of the solution is the same as the domain of the right hand side of the differential equation. So the solution, so if t belongs to an interval where both p and q are defined, then nothing can go wrong. So the solution, the formula for our solution is a valid expression, and therefore t belongs to the domain of the solution. Right? So there are three things. So here is a very simple theoretical example. Right? So if we want to find the solution of this initial value problem, then first thing we need to do is we need to rewrite it in the form where the right hand side, where the left hand side is y prime and the right hand side is the rest. And now notice that the right hand side is undefined whenever sine t is 0. So what can go wrong here is that, so if sine t is 0, then it is undefined. Undefined. So which happens if t is a multiple of pi. Right? So and since the initial point is pi over 2, it means that the domain here is kind of the biggest possible interval that does not include multiples of pi, so which is from 0 to pi. And here is the illustration. So notice that I didn't solve the equation. So the important part here is that I could figure out the domain of the solution without actually solving the equation.